Hello and welcome to the second video in this series on domain and range of functions. And I'm assuming that you watched the first video. If not, do go back and check it out. And in this episode, I'm going to extend that work a little bit further. So stay tuned with me. If I have a function like f of x equals a square root of x, and I'm asking you about the graph. Firstly, how can we graph? Okay, because I I don't feel you can find the range and the domain without any knowledge of the graphs. So how can we graph this relation? Just by taking values for x and see the values of y. So f of 0 equals square root of 0, which is 0. And f of 1 equals 1. F of 4 equals 2. And f of 9 equals 3. What do you notice? We notice that this graph is taken this form, this shape. This graph is going up from 0, starting from 0. Okay. So what are the values of x we can get? We can get all positive values of x. If we put instead of x any positive value, we can find f of any positive value. What about negative values of x? Any negative value of x is undefined. So this function is defined for all values of x which are greater than or equal to 0. So we can find all values of x, because what is the meaning of the domain? Simple. The domain means what are the values of x we can get. So in this case, the domain is 0 closed and positive infinity. Okay. Once again, what is the meaning of the domain? The domain means all values of x we can get. And for sure, we can get all positive values and we can get 0. What about the range? As you see, this curve is going up and up as x increases. Okay, so as I said in the previous session, the range is the span of y values, is the span of y, okay, the span of y values for all values of x. As you see, this graph is going up, this graph is going up. So what are the values of y we can get? Okay, when substituting the values of x, we can get all positive values on y, starting from 0 to positive infinity. What if I restricted the domain? So f of x again equal the square root of x. I'm going to try the previous example, but I'm going to write x is more than or equal to 9 and less than 25. In this case, we have a restricted domain. We restrict the domain. So if we go back to the graph I've drawn, you will find that this graph is taking this form. But because I restricted the domain and I have 9, so the first value of x we can find it's 9. So substituting in the square root of 9 is 3. When x equals 9, okay, the value of y is 3. and x is less than 25. So let's find the square root of 25. The square root of 25 is 5. It's not drawing accurately. It's just illustrative drawing. But x is less than 25 is not equal to 25. So we couldn't find the value of 25. Square root of 25 is 5. Okay? But we will draw an open circle above 25. Why? Because we couldn't find the square root of 25. So in this case, the restricted domain or the domain is 9 closed and 25 open. And what does it mean? That means we can find the value of 9. The square root of 9 is 3. Because if we go back and look at the values of x, we can find values of x which are greater than 9 and less than 25. Okay? So square root of 25 is 5, but we couldn't find the square root of 25. 25 doesn't belong to the domain, but the value which is less than 25. And I'm asking you, what is the real number which is less than 25? We couldn't know it. So in this case, what is the domain? The domain is 9 closed and 25 opened. What about the range? The range is 3 closed and 5 open. And once again, what is the difference between the domain and the range? The domain is related to related with x-axis. Okay, this is the domain. So what are the values of x? Domain is related with x-axis. What are the values we can find on x-axis? And what about the range? The range is the span of y for all values of x, as you see. They are the values of y we got from substituting the values of x. So it's the range. So the range in this case is concerning y-axis. Okay, the range is related to values on y-axis, which is 3 and 5. 3 closed and 5 open. What if I have a function like f of x equals, let's say, 1 over x minus 3? What are the values of x we can find, and how can we graph this relation? So if we looked at the denominator, we couldn't find the value of 3 because 3 minus 3 equals 0, and 0, 1 over 0 is undefined. So the domain directly, it's all real numbers except 3. Why? Because we couldn't find the value of 3. Once again, what is the meaning of the domain? Simply, the domain means all values of x we can get. All values of x we can get. Actually, we can get all values of x except 3. What about the range? Let's graph this relation. When x equal to 3, we couldn't find the value. What about something like 4? We are going to take 4. So you will get 1. What about 5? You will get 5 minus, you will get half. What about 6, 7? You will find that we have a curve, okay, decreasing, but this curve doesn't cross x-axis, What about something like 3.5? 3.5, you will get 2. What about 3 and 1 over 4 or 3 and 1 over 5? You will find that curve is going up. But we couldn't cross this line because we couldn't substitute 3. So you will get a curve. Okay. This curve is going up in this direction, but this curve didn't cross this line. What about the negative values? And 2, 1, 0. If we're going to take 2, you will get -1. If you are going to take 1, you'll get -half. Okay. If you are going to take 0, -third. If you are going to take -1, -quarter, stuff like that. So this curve is going in this direction. Okay. By taking any negative value, you will find that this line is going in this direction, but didn't. This line, by substituting a number, okay, doesn't cross x-axis. What about the values between 2 and 3? You will find this line is going down. So what is the domain in this case? As I said, the domain is our difference 3. What about the range? The range is the span of y for all values of x. So let's look again at the curve. So all values, when we go down, we will hit all values of y except 0. Except 0. So the domain, the range in this case is our difference 0. What if I have an example like this one? I have, let's say, f of x equals cubic root of x. Without graphing, I'm asking about the domain only. What are the values of x we can find? We can find the cubic root of any positive number. We can find the cubic root of any negative number. And we can find the cubic root of 0. So the domain in this case, the domain is all real numbers. Okay. What if I have something like f of x equals the 5th root of x or the 7th root of x? Okay. In this case, we can find any positive value. We can find the value of 0, and we can find any negative value. So there is no restriction for all values of x. There is no exceptions. We can find any value because it's the 5th root. Like the cubic root, we can find the cubic root of any x. Okay. And the 7th root, we can find any cubic root, any 5th root, any root, okay, odd, with odd order, okay. What about the square root of x? In the square root, we can find any positive value, and we can find 0 only. So the domain in this case is restricted or is limited. We can find any positive value and 0. So the domain is 0 closed and positive infinity. And if we have the 4th root of x, you know, in this case, we can find any positive value and 0, but we couldn't find the fourth root of negative 16. Because negative, what is the number? When we multiply by itself 4 times, we get negative 16. There is no number we can multiply it by itself 4 times and get negative 16. So in this case, we couldn't find the fourth root. So if the order of the root is odd and if the order is even. So in this case, we can find any value. We can find any value. We can find positive values, we can find negative values, and we can find 0. And for any even order of a root, we can find only positive and 0. We couldn't find, for instance, the square root of negative number. Okay, let's take something like this. 1, f of x equals cubic root of x plus 1. So in this case, what is the domain? The domain is all real numbers. Okay. What if I have something like f of x equals 1 over cubic root of x squared plus 9x plus 8. Let's analyze it simply. Because this is a cubic root, so we can find any cubic root for any value, any positive value, any negative value. But in this case, because this cubic root is written in the denominator, is written down in the denominator. So, however, we can find the cubic root of 0 because the cubic root of 0 equals 0, but we couldn't put 0 in the denominator. So what is written under the cubic root must be not equal to 0. So in this case, we are going to find the zeros of the denominator. So factorize it. X plus 8 and x plus 1 equals 0. So x is not equal to negative 8 and x is not equal to negative 1. So what is the domain? The domain is all real numbers except negative 8 and negative 1. That's it. What if I have an example like this one, f of x equals 5 over the square root of x minus 1. Focus again on the denominator. You will find that we have a square root of x and the minus 1 is away from square root. So the square root of x only. Some students get confused and say, we couldn't find the value of square root of 0 in the denominator. Yes, I know. We couldn't put 0 in the denominator, but in this case, for this square root, we can find the square root of 0. And let's try it. 5 over square root of 0 minus 1. It's 5 over 0 minus 1 equals 5 over minus 1. So there is no problem in finding the square root of 0. Do you know why? Because we have minus 1 next to 0. So in this case, we couldn't find, because it's a square root of x, we couldn't find any negative number. We couldn't find the square root of any negative number. So x must be greater than 0 only, or equal to 0. Y is equal to 0, I explained it, because we can find in this example the square root of 0. So x is greater than or equal to 0 we can find all values from 0 close to positive infinity. But we couldn't put 0 in the denominator. We couldn't put 0 in the denominator. So find the zeros of the denominator. Square root of x minus 1 equals 0. Okay, so square root of x equals 1. By squaring both sides, you will find that x equals 1. You know, 1, if we put 1 instead of x, let's do it. If we put 1, 5 over square root of 1 minus 1. It's 5 over 1 minus 1, which is 5 over 0. You know, we couldn't put 0 in the denominator. So what is the domain in this case? The domain, lastly, we can find all values from 0 to positive infinity except 1. Did you get it? I hope you enjoyed this session and see you in the coming episode. Goodbye.